Nuclear reactions occurring in the sun provide energy to the planets surrounding it. Electromagnetic radiation released from these intense reactions travels many miles from the sun, passes through the Earth's atmosphere, and provides us with energy. There are different regions of the electromagnetic spectrum. Some are essential for life, while others are hazardous to our health. But how much exposure is enough, and how much is too much? Can too much exposure to the sun's radiation damage your health? What methods of sun protection are most effective? Are there chemistry products that help protect us from overexposure? Do chemical reactions in the Earth's atmosphere protect us from harmful radiation? In this chapter, we will learn about the sun's radiation and how chemistry can protect us from overexposure to the sun's harmful rays.
In this chapter, we're going to be talking about sunlight and all different forms of light. Sunlight is a form of electromagnetic radiation, and all different forms of electromagnetic radiation include radio waves and sunlight and microwaves. And it's different from radiation that you might think of that's used for cancer therapy. That's called nuclear radiation, which we'll get to in a future module. Some forms of electromagnetic radiation are dangerous, but most forms are not. Now, sunlight does have some danger to it, which is why you protect yourself when you go out in sun. Do you wear sunglasses when you go outside to protect your eyes? Or do you wear sunscreen when you go out into the sun? What are you protecting yourself from? Not just sunlight, but there's a portion of sunlight that is harmful, and that's UV radiation. That's part of sunlight and only a minor part of sunlight. So when you are wearing sunglasses or sunscreen, you are protecting yourself from the UV radiation that comes with sunlight and that has high enough energy to break bonds in molecules. Continuing on with light, do you need to wear sunglasses and sunscreen when you're exposed to indoor light or a flashlight? Light that's called visible light, light that you can see, that's indoor light, the flashlight, that does not have this portion of harmful UV radiation. So you don't need to wear sunglasses or sunscreen to protect yourself when you're exposed to indoor light. So we can get rid of that. It's important to understand both the positive and negative implications of sun's radiation. So on Earth, we're all exposed to sunlight and that portion of it that's UV radiation. There's positive, and we get benefits from sunlight. What are the benefits? Well, a suntan. So a suntan is different depending on one's skin type, but can also lead to sunburn. That's a negative. The other positive of sun exposure is vitamin D. So you actually need vitamin D for your human metabolism, and you can take a vitamin D pill, or you can expose yourself to sunlight, which will initiate the reactions that produce vitamin D in your body, and that for 10 minutes a day, you can get your vitamin D for free rather than taking a pill. And finally, sun's radiation is really important in maintaining Earth's temperature. So the major portion of sunlight is actually not UV, it's not visible light, it is infrared, that's heat. The sun brings heat to the universe and, most importantly, Earth, and it warms our planet to a habitable temperature. But we do have the negatives of sunlight, which are sunburn, and long-term effects include aging of skin, like wrinkles and sunspots, and also skin cancer is dependent on your skin type. Some of the questions we're going to cover in this chapter are the types of radiation that are coming from the sun and which are dangerous. We also want to look at the link between sun exposure and skin cancer, and how to protect yourself from sun so that you don't get skin cancer. And then finally, one thing we're really lucky about is that Earth provides us from natural protection from sunlight. Earth's atmosphere naturally protects us from the majority of harmful UV radiation coming from the sun.